Hey everyone, welcome to another episode of HPC in the Cloud. I'm Joe Schoonover from Fluid Numerics, and today we're going to be talking about some common mistakes that folks often make when spinning up their first auto-scaling HPC cluster on Google Cloud Platform. So let's just go ahead and get started here. Now, if you're following along with the demonstration today, you'll want to go ahead and create a Fluid-Slurm-GCP cluster. You can do that if you start at console.cloud.google.com. Click on that Products and Services menu in the top left corner, head on down to Marketplace, and look for Slurm. And you can choose any one of these three solutions, either the OpenHPC, Ubuntu, or the classic CentOS solution that we have there for you. Just go ahead and follow the prompts as you go through the Marketplace. If you hit Launch, it'll bring you to a form to fill out to get your cluster up and running. Now, I've already created one for today's demonstration, so we won't need to do that. But by the time your cluster is up and running, you'll be at the Deployment Manager page. It should look something like this. You'll see the Slurm logo there, and then of course the stuff for getting started, including an SSH button, which will dump us right into the login node. I actually like to go ahead and head on over to the Compute Engine page so we can see both the controller and the login node. And let's go ahead and open up an SSH window for our login node. Now, the first error that folks usually run into is as soon as you get the cluster up and running, we immediately just want to start getting to work, right? So let's just see what happens when we try to do that right out of the gates here. So I have on this cluster a single partition. It's got a C2 standard 30 compute instance type there in that first partition. So I'm just going to try to run a single task. And right now, let's just run hostname, something simple. And right off the bat, you'll see this error. If you've ever seen this before, unable to allocate resources, invalid account or account partition combination specified. What this means is you have not actually set up the Slurm accounting for your cluster yet. So the Slurm controller actually doesn't know that you're allowed to be submitting jobs to the partitions. Now, there's two ways you can fix this problem. One way is to actually use the S-Account Manager tools to create a Slurm account for yourself and give yourself permissions to submit to that particular partition. The way I'm going to show you today is actually using the cluster services tool that's installed on all of our clusters. What you'll need to do is go root. Now, if you can't go root on your cluster at this point, stop, talk to your system administrator and ask them to set up that Slurm accounting for you. But if you can go root, go ahead and run sudo su, and then we'll run cluster services list all to create a cluster configuration file. You'll dump that output using that right caret there to a file called config.yaml. Then what we're going to do is we're going to sample a Slurm account block. Okay, and we're going to append that to the same config.yaml we just created. So let's open up that file. I'm using Vim. Feel free to use whatever your favorite text editor is here. Let's get some line numbers on. What I'm going to do now is take that Slurm accounts block here on line 43, cut it, and paste it down below, and then let's get rid of that white space and that empty array specifier. Now, for the allowed partitions, this is going to be any array of strings here that are going to basically be representative of the compute partitions you want each of your Slurm accounts to be able to submit jobs to. Since I've only got one partition, it's called C2 standard 30. That's all I'm going to put there, and we'll go ahead and remove that of the line. The name here is the name of the Slurm account. I'm just going to call it demo account for myself. Of course, you can choose whatever you like. And then under the users, you'll put your POSIX username and any other users on your cluster who need access to those partitions. Once you do that, we can run cluster services, update Slurm accounts, give it the configuration file with that ---- config flag. Now, let's first run a preview so we can double check our work before we actually make the changes. So now if I run sinfo, I just want to make sure I'm getting the name of that partition right. I got C2 standard 30 there and C2 standard 30 there. It's looking good. And of course, that's my username. So I'm going to go ahead and just rerun that command without the preview flag. And let's now go ahead and try to run this job now that we've got the Slurm accounting set up. So we'll say srun -n1 hostname. All right, so this is going to sit in the background. Now, what's really supposed to be going on in the background here is the Slurm controller daemon recognizes a job that needs to be done. All the nodes are in a cloud state right now, so it actually tries to go and spin up a compute engine instance. And there are a number of things that can prevent that from actually happening. So let's see if we're actually getting that instance to be created. So I'm looking back at that compute engine panel. Going to hit refresh. Looks like it's starting to come online here, so we'll give it a few minutes to spin up. While this is coming online, I did want to point out another service on Google Cloud that's going to be helpful as we go through the tutorial today, and hopefully for yourself in the future whenever you're trying to debug issues with various Google Cloud services. So if you go on that products and services menu on the top left side here, we're going to scroll down to the, I believe it's the tools section. No, operations. And we're going to go down to logging and the logs explorer. Go ahead and bring back the compute engine in another tab. Okay. So the logs explorer is a place where a lot of logging information happens related to all of Google Cloud services. So if you ever try to create, for example, compute engine instances and they don't get created, which is what should be happening here in this particular setup here, you'll be able to actually see all the error messages and everything that could have gone wrong with those types of activities. You can see here, this last log here is showing that we did actually make a compute instance insert. So if you click that drop down arrow, you'll be able to see more details about the details of that call, who made the call when it was done, and then if there are any errors, what those errors were. Let's go ahead and expand those nested fields, and you can see, for example, you could see right away who made that call here, and that was just our default compute engine service account. It just gives you a lot of helpful information for really diving into what could have been going on in your system. Let's take a look at what's going on here. And it's still trying to spin up here, so we might be having some problems. We'll give it another minute. Let's refresh those logs, see if anything new comes in. Now, I guess at this point, let's go ahead and hop onto the controller here, so I can point out some other spots on the Slurm cluster where you can get more information about what's going on here. So we're going to go ahead and open up another SSH window into the controller. So outside of this logs explorer, if you're on this cluster, go ahead and go root, and we'll go look underneath the app-slurm log directory. So generally there are 4 types of log files that are going to be under here. Right now you only see 3, and I'll explain that why you're only seeing 3 in just a minute here. But right now we have the resume log, Slurm controller daemon log, and the Slurm database daemon log. Now the resume log contains any sort of feedback from the script. It's called the resume script that's used to actually provision compute resources for you on the fly. If there's ever any problem with nodes spinning up, you'll usually find some information here. So if I take a look at that resume log, right now it doesn't show that there are actually any errors that came out of here. It says that it tried to burst out that C2 standard 30. So there's not really any indication of a problem quite yet. But if we take a look at that controller daemon log, you'll see that first time we tried running a job and we didn't have the Slurm accounting set up, you'll see that error message actually recreated inside of here. And we're still not seeing any errors yet associated with that job we just ran. If I hop on back to that login node, you can see we're still waiting for that job to start. We take a look back at that compute engine panel, and now that compute node's actually gone. So this might be a behavior you've seen before, and you're probably asking yourself, what the heck's going on here? Let's dive back into that logs explorer, or refresh the page, and see if there's anything new there waiting for us. Okay, so now we have a new log at the top here. You can see it's got the it's that orange yellow color with the exclamation points here. Let's go ahead and drop down the listing here of that feedback on that log, and let's expand those nested fields. So when you look in the nested fields, underneath that status metadata there, you'll see what the problem was, why that particular compute instance didn't come online, and you see we've got a quota exceeded error. What this means is on your GCP project where you're trying to create the compute instance, you haven't actually asked Google for enough virtual CPUs or GPUs or disk space, whatever it is. So in order to fix that problem, what we need to actually do is head on over to the I am an admin menu and go into quotas. So once we're under here, we'll go ahead and look through the quotas that we have for the C2 standard nodes. I'm running right now in Europe North 1, so we'll make sure we just start looking just in that particular region. Okay, so we'll filter the table. We're going to look at the service is going to be Compute Engine API. So we can just scroll down there, and then the limit name. Whoops. Limit name. We want to look just for the C2 CPUs. So let's scroll down there until we find C2. There we go. And let's go ahead and open that up and look at all quota. Now, virtual CPU quotas are actually done by region, so all of these zonal listings here are actually not going to be relevant for you. So just go ahead and hop over to that last page for the quotas. And here we got Europe North 1, and you see I've only got 8 C2 virtual CPUs that I can actually use. Now at this point, if I were to actually go through and correct the error, you'd click that box here, hit your edit quota, and fill out that that form that shows up on the right hand side. And generally it takes about 12 to 24 hours for Google to get back to you. Sometimes even longer if you have a very large request. But that's how you'd fix that particular problem. This is a common issue we see with folks where, like, you create the cluster. We've got right now. I've got 10 nodes in the Slurm configuration with C2 standard 30, so a total of 300 cores. But I actually don't have the GCP quota, so it caused a problem. But that's how we were, basically using the Log Explorer and just taking a look back to that quota was just the quickest way to go through and resolve that issue. So let's talk about another problem here. So another issue we usually see is when folks get their cluster for the first time, and all right, we've got our first partition in there. Now we want to start adding other partitions, like maybe for instance something with GPUs. So let's go ahead again and go root. Here I am on my login node. I'm going to run. I'm going to open up that config.yaml. I'm going to create another partition. I'm going to add GPUs to it. So this is going to be. Add line numbers here. So we got line 22 all the way down to 42. We're going to copy those to create another partition. Paste it down below. And on this one, let's go ahead and say 1 GPU. We're going to do a V100 GPU. And just something to keep in mind, GPUs can only be attached to N1 standard or N1 instances. Let's go ahead and say N1 standard 8. Don't need a whole lot there. Let's go ahead and change the name. We'll call it N1ST8 V100. And then for the partition name, let's go ahead and also call that N1ST8 V100. All right, now let's preview these changes. All right, let's do update partitions. Config equals config.yaml. And let's preview first. Whoops. There we go. All right, so you can see it's going to add a new partition for us. Of course, there's the name of the partition, N1ST8 V100. We got that same name for the machine block. We've got 10 of those nodes. We're going to run N1 standard 8. This is all looking good so far. Let's go ahead and try to run this command. Okay, comes back pretty quick. But hey, I don't actually have the new partitions. Now, some of you who've been using our system for a little bit now know exactly what I just did wrong here. So if you ever have to update your partitions, you actually have to do this on the controller and not on the login node. And there's a few reasons why, but the main one here is in order to apply partition updates, you actually have to restart the controller daemon, or at the very least reload that slurm conf file after it's updated. The easiest way to do that is just to make sure you're doing those changes on the controller. So I'm going to hop over to that controller here. Let's clear that screen. I'm going to go back to my home directory, and I am still root, right? And I still have that config.yaml file there. Let's go ahead and run that cluster services update partition command here on the controller rather than on the login node to get those changes to actually apply. Now, if you've ever done something with cluster services and it's messed up the cluster, or in this case we ran something on login node and something didn't happen, if you ever wanted to try to figure out if there are any error messages or anything else that would help us at Fluid Numerics help you diagnose the issue, if you take a look underneath apps CLS log, there's another log file there for you. It's the cluster services log, and this will help us kind of understand the types of activities you've been trying on your system in case you get it to a state where you really just don't know how things went wrong. Let's take a look underneath there just so you get an idea of what that log contains. It will always tell us the date timestamp. It will tell us the basically standard out and standard error messages that come out of running cluster services internally, and it will also tell us which instance you are trying to run those on. So it can help us in case you're just getting stuck. It'll really help us quickly identify what could possibly be going wrong on your system. Okay, so now that we've applied this change, let's look at sinfo. Now we've got this N1 standard 8 V100 partition. I'm going to hop back on that login node. We do need to actually update the Slurm accounts now that we've got a new partition. So let's go ahead and do that. Now, updating Slurm accounts, you can do that on either the login node or the controller. I'm going to go ahead and do it on the login node here. So under the allowed partitions, let's add N1 ST8 V100. Okay. And let's go ahead and update those Slurm accounts again. Okay, let's preview that change first. Okay, it's just going to add that new partition to that first Slurm account block. That's looking good. And we'll go ahead and run that. And let's exit out of root. Cool. Okay, so let's try to submit a job now to this new partition that we have. All right, the N1ST8 V100. And let's, since we're on GPUs, we're going to need to use the gres flag to specify that we're looking for a GPU. So we'll do one task minus gres equals GPU. Just one GPU is fine. And let's run NVIDIA SMI. And this will just basically give us some output showing that the GPU is there. Okay. Interesting. Now we're getting this new error. It says unable to allocate resources. Requested node configuration is not available. Let's take a look at what's going on here. So I'm going to hop back on the controller. Double check. If you look under app slurm current etc slurm.conf, this will show you the slurm configuration file that's currently being used on your cluster. What we want to do is make sure that, hey, we do have a GPU inside of here, and should be good to go. Let's take a look. So we got partition name N1STV100, we got cores, and then yes, we do have a gres for GPUs inside of there. Okay. And then the other one to check is your gres.conf. Make sure that that has some information in there. It should tell you the node names, it should tell you what type of generic resource is available on that, and then if you do have multiple types of GPUs, you have this further type filter here. Here we got V100. Okay, so that's looking okay. So the other thing that could be going wrong here is perhaps a consumable resource like memory is defaulted too large. Let's take a look. So if I just said one way to get around this is to go through and let's add a memory flag here and just say, whoops, mem equals 1G. Is it mem or memory? I think it's memory. So what I get for doing a live stream where I'm breaking things, I'm still getting unable to allocate resources, requested node configuration not available. Okay, so the problem here is actually I'm not actually specifying the partition I'm trying to run in. So if you notice up here on the, let me clear the screen here. If I run sinfo, we've got the star next to C2 standard 30, and then this one doesn't have a star next to it. So the star next to that partition name really just means it's a default partition. And if you don't specify a partition, it's going to try to run that job in that partition, but the C2 standard 30s do not have they do not have the GPUs attached. Hence, we're getting this error. So let's go ahead and add that partition specifier in here. So we'll say N1ST8 V100. Whoops, and I don't want to run that. I want to run NVIDIA SMI. Okay, so we got the srun command here. Let's hop on that controller and take a look at the resume log and see what could be, if there's anything going wrong here. So app slurm log, resume.log. And we got an error. It says add exception for N1ST8 V100-0. That's the name of the node that tried to get spun up. And we've got, what is it? The resource, projects, project ID, accelerator types, NVIDIA Tesla V100 was not found. Okay, let's, just to show you the consistency between this error and what you would see in the Logs Explorer, if I come back to that Logs Explorer, we'll refresh that page. Okay. Now on this page, you see again, we got another error in that Logs Explorer. So we hit that drop down, expand those nested fields, and it shows us that same error message. Really just pointing out to you that there are, you will start to see consistency between some of the stuff that's reported on the cluster and things that will show up on that Logs Explorer, giving you some sort of faith that you have consistency in what could possibly be going wrong here. Now the issue is when you see an error like this, that a resource is not found, usually what that means is that Google actually doesn't offer that resource in the zone you're trying to spin it up in. That's particularly true with like C2s, N2Ds, E2 instances, in any type of GPU. Usually these are only available in certain zones. So let's take a look. Let's just look up GCP GPU zones, okay? And let's take a look at the NVIDIA V100s and see where those are actually available. So if you scroll down through this list here, we got NVIDIA V100. Okay, that's just telling us the types here. We want to know the zone. Did I pass it? Let's see here. GPU regions and zones, here we are. Okay, so if I look, I'm in Europe North 1 right now, so let's see if are there any GPUs in Europe North 1. And actually, I don't even see Europe North 1 on this list, so let's just double check just by North 1. Okay, so North 1, A, B, and C, they have no GPUs available. There's nothing in those rows here, but let's see where we do have V100s nearby maybe. So we got Europe West 1. No. Here, let's just do a search for V100s. There we are. Europe West 4A, B, and C all have V100. So let's just go ahead and update our cluster config so that we can get that in the right zone. And again, remember, since we're updating that cluster config for the partitions, we're going to go ahead and do that on the controller. So let's open up that config.yaml, and let's change the zone to Europe West 4. Now there's two things you have to do in order to change zone. One, obviously, change the zone entry in that machine block for that particular set of machines you're wanting to move. And then of course, if you change zone, you also have to, if you change region, you also have to change the VPC subnet, since the subnet is tied to a single GCP region. So here, since I'm using default networking, it's pretty easy because they already have subnets already built out for every GCP region that's available. So I can just come here and right next to where it says regions and before subnetworks, insert Europe West 4. Okay. Now, if you have your own custom networking, just make sure you also go through the process of creating another subnet and make sure that the subnet CIDR range is also included in the firewall rules to allow communication on your internal network. Okay, so I'm just going to change that to Europe West 4. We're going to rerun the cluster services update partitions. First, let me go through and cancel this job because I know that's going to fail at this point. So let's go ahead and update partitions. Config is config.yaml. And again, let's preview, make sure we're doing okay. So yeah, we're going to change subnet and the zone. Everything's moving to Europe West 4 here. So let's run that command without the preview flag. Again, make sure you're doing all of this on your controller, as otherwise those changes will not apply. All right. So let's try running that job again. Okay. So if I run that again, let's check that resume log. App slurm log resume.log. This time we didn't get any error, which is good. Now, so long as I have quota, this job will go through. So let's take a look at the compute engine panel. We can see it's coming up. While we're waiting for that to spin up, let's take a look at the quotas that we have available. So I'll go back out of here, out of the C2 CPUs. Let's look for limit name is going to be V100 GPUs. Let's just do a search for that. NVIDIA, as a committed, I don't want committed, just want the NVIDIA V100 GPUs. 1 out of 99 quotas are reaching limit. Cool. That's what I was hoping for. All right, so I do have 1 GPU available in Europe West 4 in my quota. So if I were to try to do any more work in this region, those next set of nodes that would be provisioned would actually fail to come online. Let's refresh here. It's still spinning up. But in general, I was like really hoping today just to show you some common mistakes that folks usually make, and it usually comes down to these simple things like not having enough quota, or not configuring the Slurm accounting, or just not even placing instances in the right zone. I know it's a lot to keep track of, but as you work with Google Cloud, you'll start to build more familiarity with all these things, and your life will get easier over time. So let's kind of review a little bit. Some things you could do to prevent, I guess, encountering these common pitfalls. So let's kind of go over a pre-launch checklist here. So we have, before you spin up your cluster, it's always good, I know we didn't cover it today, but it's always good to check those identity and access management permissions for yourself. Usually if you're starting a project from scratch, default permissions that come with your project usually are enough for yourself, but if you're adding others to your cluster, you need to make sure they have the compute OS login and service account user permissions at the bare minimum so they can SSH into the cluster. The next round here, again, something else we didn't touch on today, but it is important to look over, is using firewall rules. Now this is, again, not a common issue folks run into because the default networking that comes with your GCP project usually has everything you need to get up and running without any issues. But if you are using custom networking, some things you want to make sure is you have TCP/22 open for the outside world, at least for the IP addresses where you're going to be SSHing from. And we highly recommend that you do limit it just to that rather than keeping it wide open to the entire world. And then, of course, internally on your network, you need to have a fairly wide range of ports for TCP ports open so that things like MPI, the Slurm controller daemons and Slurm daemons can talk to each other. NFS mounts can all basically be mounted across that cluster. Again, that default networking usually does the trick, so most people don't actually run into this when they spin the cluster up from scratch. Of course, the ones we did talk about today are the quota and the zone compatibility. Make sure that you have quota for the types of CPUs you have in the regions you're deploying them. Same goes for GPUs and disks. All right, and then of course zone compatibility. If you're going to try to put GPUs or C2s or N2Ds in a particular region, double check some of that GCP documentation to make sure they're available. Now, in the eventuality you do run into a problem with running your cluster, remember there are 3 places you can look. The first 2 we did talk about today. This is app/slurm log. There's those 4 log files underneath there: the resume log, suspend log, Slurm controller daemon log, and the Slurm database daemon log. All of those are very helpful for building the history of what's gone on in your cluster and what could possibly be happening. It could help you resolve your problems quicker. And of course, if you ever reach out to us, if you send that information to us, it really helps us dive into those problems alongside you. And of course, var log messages is just the general system logs that tells us a lot more about what could be going wrong on your system. For example, if certain daemons or system D files are not, or system daemons are not coming online, var log messages is a good place to find some of that, the source of those potential problems. Of course, outside of that, if there are actually issues with GCP services not being provisioned, you can always use the Operation Logs Explorer just by going through your Products and Services menu, going down to the Operations, and looking for the Logs Explorer. And that will help you determine what could be going wrong if GCP instances aren't actually being created. Now, with all that in mind, of course, you can always reach out to us at Fluid-Slurm-GCP at fluidnumerics.com, and we're happy to help you. So I hope you guys found this useful. Thank you for joining me, and I look forward to seeing you guys next time.